Great, thanks. That was a nice presentation today. And now we are about to discuss what's their main issues, wishes user community has for their synchrotron facilities. And before that, we would like to start with an online survey that actually will take only a few minutes. And Stella, can you explain what we should do?
I just sent a link, the second one, and please go in and reply to one of our questions on whether you are satisfied with the current synchrotron capabilities. Okay. And I shall slowly start sharing my screen so you can all see the result. So we have 53 responses so far. So the question was if you're satisfied with the current synchrotron capabilities. The largest, most of the people replied yes, but they need more alike and or more time so far. We have a response that is equally large as yes. They think they're satisfied with whatever is currently available. And we also have a good amount of people that believe that this is moderate, then there is room for improvement. And some people that believe that somewhat, because there's still some improvement and need for improvement and availability. It seems we have stopped around 53 responses.
Great, looks like no one say no and no one say partially. That is good. At least we are doing pretty good job. If it's almost 60% satisfy what we have, and of course we need improvement. It's a life, so every day should bring us new purpose and new goals. Without the goal, we cannot live. It's great. Yeah, go ahead.
Oh no, I was gonna say it would be good to see a cross correlation with how many students answered there, or staff, or who are the folks that are satisfied or not satisfied. Just point of view, I guess, more than anything. Maybe next time.
Yeah, maybe next time, because that question doesn't have this, but we know that approximately what it was like 50% we have students and postdoc as our attendees.
Thank you.
Great. So Quentin, do you have any comments?
Yeah, of course I have comments. What I would say is what this illustrates, and I can't say that I'm surprised by the results, is that in this country, we obviously, and worldwide, we have a finite number of synchrotrons. We have really not too much of a prospect for growth of beamlines per se. There may be a little bit from what we've heard today, but not much. And I think what we have coupled with that is we have a clearly growing community. As I scroll down this list of names, there's a lot of relatively junior people on this call. So I think the fact that almost 40% of our folks basically said we need more stuff, we need more time, is actually a reflection that this is going to be a need which will be difficult for the community to furnish. I think our upgrades are fantastic that are taking place, but I don't know that the improved intensity, while it may produce viability of different classes of experiments, I don't know that it will dramatically accelerate the rate of experiments per se. There is a finite rate that you can proceed with high pressure experiments. So what this drives home to me is that beam time itself is currently viewed as not fully sufficient, and that the current round of upgrades and the current prospects for the community do not necessarily drive us towards vastly more beam time. Let me put it that way. I mean, there are incremental changes that are taking place. And I think that's something that is of concern for the community moving forward on the decadal timescale, because we are producing more and more folks. We have a highly saleable community that's getting more academic folks embedded within it, and more groups. You know, the proliferation of number of high pressure groups just in the last 2 decades has been enormous in the US. And so I see that there is a real major, for lack of a better word, time crunch. And that's not counting a couple of synchrotrons going offline in the next 5 years for a year. So that would be my take. Happy to have others pontificate for a moment on it. I get to pontificate because I'm co-moderator of this session.
Well, we could look at it the other way. We need more stations.
More time available.
Yeah, but if the stations are saturated, then we need more stations to get more time.
Yeah. Suki, do you want to tell your comments to everyone?
Sure. So I was just noting that, you know, although we have this this majority of people who are saying that they want more time, one of the things that we also see is that there's a majority of people who are satisfied with the capabilities. So as Quentin pointed out, you know, some of the you know, we can discuss, I think, you know, how much we are fundamentally changing the science with the upgrades that are coming online. So, I mean, if we are satisfied with the available techniques, does that mean that we are not following along with the speed of scientific developments and synchrotrons, and that our community overall needs to be catching up to leverage the newest science?
Yeah, it's a great point, but you also could see it from other side. If you reply satisfied, it means that currently what you are doing capability is enough. And the goal of this workshop is stimulate you to think further and think about the new capabilities that will open soon, and basically bring your research to this level. Yes, that's what.
So, Vitali, can I ask a question to the community, and probably the ASRF folks probably can answer this more? Is with the upgrade, are they discussing about less downtime for maintenance in between cycles? Or, I mean, it should be newer facilities, so hopefully maybe less maintenance, but I don't know. Does anybody know about it? Still the same?
I mean, the APS has had the same basically downtime schedule since they started running, right?
Oh, so it's, yeah.
It isn't, they don't have the current schedule because the machine is getting old. There may be, if there are a few more unexpected downtimes than they would like because the machine is getting old, but I don't see that happening. I mean, a day a week and the 3 1-month shutdowns is probably going to happen.
So we're not going to gain any extra time.
No, I mean they're gonna tell DOE that they're delivering 5,000 hours a year, right? I mean that's what all the synchrotrons do.
Yep.
Is there any other comments? Is there anyone want to tell about the current capabilities that we have in US and worldwide that they can use for their research?
Well, I'd like to return to Suki's point for a second, which I think is a good one, which is that you know, there is always with this type of poll a degree of conservatism attached to them, in the sense that folks, you know, are, you know, thinking about what they were doing this month, next month, and in the next 6 months to a year time frame. And the question is what are folks going to be doing 10 years down the line? That's the extraordinarily difficult part of this, to basically not only convey to the community, but also to you know, sort of tap into folks's you know, visions of the future, because you know that there is, I do not think that you know, from the perspective of 15 years ago, where everybody was just doing powder diffraction under pressure, chugging away nicely and quite happily, we would have probably gotten the same result. So I don't think it's that we're lagging the synchrotron technology per se. I think it's more that there just is an intrinsic conservatism, and that as techniques come online, folks get engaged with those. And so I think that's an intrinsic thing, that the development is kind of non-linear, and it is not readily predictable in synchrotron science necessarily. That would be my general analysis. And now finally, I've got a hand up from Paul Duffy.
What do you mean? It's like what we development sometimes at the synchrotron, so we can stimulate the research. So
Right.
basically, even the users are not requested the stuff, but as soon as we get their smallest beam, they immediately new proposal with their new ideas will come in. Yeah.
Right, or another example might be inelastic X-ray scattering, which seemed like a really niche technique 15, 20 years ago that a couple of happy physicists were playing with, and has now become a much more common tool within the community.
Yeah, we have a bunch of examples like this. Yeah, like a pulse laser heating, for example, it was not requested by users, so it was collaborative work, and then it's now almost 90% of users can use it because it's safe for diamond tunnel cell, and you can do some research that was not be able to do before. So, it's good.
Tom has his hand up actually, and
yeah, I'd like to I agree with Quentin's point, and one thing that's been very noticeable is and in many ways it's a compliment, but we used to get, in a given run, we used to get much more time than we get now, and that actually reflects a very efficient and well constructed facility that we can be productive in a short period of time. But it's also not always the best for educational purposes when you have an extremely limited amount of beam time. But the point I'd really like to make, though, is with this new larger organization, hopefully it gives us more weight and more pull. I mean, there are opportunities for greenfield, brand new beam lines at various synchrotrons. They're very expensive and they're hard to get. But, I think, a good objective for this new organization is to be able to mount some efforts to get those, because we really do need more stations, as Yanbin said, and one way to do that is more beam lines.
Right.
Yeah, it's right. The more it will be better, especially for the training purpose. If we can have like dedicated beam line, whereas most of the students will be encouraged to come in and do their PhD there, gradually learn how to use what is their diffraction and what the imaging, the physics and behind that. That will be great, yes. But that will require quite a bit of funds. So it's running another beam line. It's not very cheap. Yeah, there are some options that we can have. Even at the APS, there are a few banded magnets that are empty, and we can still jump in and convert them to the suitable technique.
And chess also has opportunities. NSLS must have as well.
But those are going to be truly greenfield and very expensive. But hopefully you get them to pay to build it. You're a partner user.
Right.
But there is the ancillary expense as well as staffing those beam lines, which the current NSF funding I would not regard as sufficient to staff, let us say. I think it's a great idea, Tom, don't get me wrong. But staffing those beam lines will be very, very challenging under these circumstances. I mean, we can invoke that there might be, in the post-COVID world, there might be really have been dramatic advances in user automation and so forth that could help in that respect. But I still think you need a beamline scientist or two per beamline to make things really run well. I might be wrong on that. I could easily be wrong in 5 years on that.
So I think actually APS, after the upgrade in the new governance model they want us to sign, they're like requesting, I think, like 3 or 4 scientists per beamline, which, I mean, there's no one has that many, but that's what their goal is. So yeah, the cost will go.
Or at least people per beamline.
Yeah, right.
Not necessarily scientists.
Yeah. So it is actually incredibly challenging, and I mean, I totally agree that a greenfield, new beam lines would be marvelous, but we do have to look at how at clever ways to pay for these things too, and actually staff them adequately, which ties in with Suti's comment in the chat as well.
Yeah, unfortunately, like what Tom has pointed out, like, I know that when for example, JCCars 20 years ago, each user group has 3-4 days for beam time. That actually was very relaxing, but now they have only 1 day. And it's very intense. It's for comparison, it's almost like Excel. So as soon as we develop very expensive technique and well-maintained, then yes, each second is a treasure. So you have to use it. But yeah, I agree for the, it's very challenging for the young students. But even from our experience, and Stella can confirm, recently she has a lot of experience with the young students, first coming to, first doing experiment, and believe it or not, they are catching very fast. Like within couple hours, they can control the beamline themselves. So only they need the guidance from supervisor, where to go and how to go. So it's kind of like trade-off between, but yeah. Is there anyone else has some comments? Yeah, actually, another question to discuss is there what the new capability are most needed? Is there anyone from user community think that what, especially the one who replies that improvement is needed for the beamline, what they think is not enough right now? What's the main area where we have to improve? Yeah, I guess answer should not be anonymous. I can point it out and say, okay, what do you mean?
I guess that was me. I was thinking
hi,
about
June.
DCS though. Hi. So I was actually realizing that my answers are a bit skewed because I've been all the negative things are about DCS. I'm sorry.
John, you cannot be
not
alone.
your beamline. Don't worry.
Yeah.
But
But another thing I wanted to say was that I think that you know, of course we always want more beam time, and so I think that that being one of the consensus points in the you know, the survey we just did, I think that that just means that we're just all scientists, and of course want more beam time. I think that you know, as the data comes in, a lot faster, I think that you know, continuing the trends from all of the accessibility gains we've made during COVID, I think that being able to control remotely, increases access, especially for the young students as well, and having them be able to participate in class. I think that if we can, more efficiently get, experiments, on and split time, I think, just we can get so much more data than we used to be able to. And so maybe, building out, the ways that we can get data out faster could be something that we could think about instead of making a new beamline or something.
I mean, to collect more data, yes, that's what we'll have at after APSU. So it's called like brighter, faster, and yeah, and that's what we'll have. But
Nice,
it's
great.
yeah.
Yeah, so more resources for our postdocs, I think, or beamline staff, I think to support this, because I think that you guys have been doing a lot of remote beam times for people where you've been doing all of the work, and so I think that we need more, to be able to support more remote, we need more full-time staff.
Yes, for the remote operation, actually, it's drive us crazy. So for the 1.5 year working in remote mode, it's like no time for anything else. And still, like within that pandemic, was be able to introduce new technique. We have a new users group, completely new, fresh, never used synchrotrons.
Yeah.
So it works. But yes, more stuff will definitely help. It's helped a lot. And
it's not sustainable, I think, at the current level, but we need to sustain it at some level, because it has opened it up to a bigger group of potential users. Exactly. Undergraduates at people at undergraduate institutions where they don't either have time or money to travel to a synchrotron, and so we need to. I don't think it's sustainable to have all the experiments be remote. We need the people who can come to come, but we need to make it so that people who can't come. I think I would argue on the data thing is that I'm not sure how, I don't think the high pressure experiments are necessarily to the point where where the majority of users are swamped with data, but certainly in the tomography, the needs are not in being able to collect the data faster, it's being able to handle the data. And the role of the synchrotron in doing that, I mean, is something that needs to be looked at. Because it's gotten to the scale where most users don't have the resources at their university to be able to handle the volumes of data they're collecting.
Yeah. So Mark, it's back to your question about the remote. So having like a hybrid availability for the users to have a hybrid access to the synchrotron, partially remote and partially on site, that will help a lot.
Right. I mean, you may need to just put a quota and say, you know, we're going to allocate a third of the time for remote experiments or something.
Yeah, I think there've been a lot of really interesting, questions brought up or discussions at the IUCR last week in terms of, our responsibility in terms of, storing and sharing data. And there are a lot of people talking about crystallography data being all collected and slowly mined through by AI. This is something that I think is becoming standard in protein crystallography. And so it was really interesting. I think whether the data should be managed individually by PI or if it should be something that we collectively.
Oh, you mean that data available for everyone? You collect it at some pressure point and it's available to everyone who wants to analyze.
Yeah. That's the direction that I think that science is going also. And, but imagine, yeah.
Unfortunately, at the high pressure community, no one wants to share data until they publish.
I know.
That will be kind of like difficult to.
This is what you missed at IUCR last week or 2 weeks ago.
With the protein crystallography, I even don't want to touch that.
The required amount of metadata to make sense of the data is much larger in this field, and you got to solve that problem.
But we'll get there. Yeah.
How do you capture that metadata and force people to release that metadata?
Yeah. So yeah, maybe a postdoc to think about that or something. Kind of like how we had the compressed supported person at the APS. What was that called? It was like Bin Chen's position.
Comtech.
Oh, Comtech.
It was Comtech.
Yeah, I thought that was the value added from a position like that. I thought was really great. I feel like what Bin and what Jin did.
Okay, Martin, do you have some to say?
Yes, this is maybe somewhat related to what June just said. That's actually an interesting idea that every PT point ever measured is being made available to everybody. But I think me as a scientist, if I wanted to use some random person's PT point, I would have to want really confidence that this data were taken in a reproducible way. And this brings me to a problem, I think, in the community, which is the cause of a lot of irreproducibility. That's the way samples are prepared. They are basically prepared by skillful or not so skillful grad student, and the reproducibility of sample preparation is very limited. And I think one thing the community has to start thinking about it is building facilities and making them available to users, which allow very reproducible sample preparations, using FIVs and high-tech, the currently available high-tech facilities.
Yep. Okay, then Shim.
Yes, I like to add some comments about the more beam time argument there, because we heard this morning or all the afternoon from NSF that they really want to emphasize equity and support minoritized groups for the educations. And I found incredibly difficult to bring undergrad students to, for example, like 1 day beam time or 2 day beam time. I tried a couple of times and I found awkward situation where graduate students are so focused on finishing their experiment within a few hours that they literally really couldn't think about, working with undergrad students. And I try to reinforce the, communication there, but I also feel guilty because they need to finish their work within an hour or two so that others can fit into. So that actually unintentionally sort of discourage the opportunity for us to bring undergrad students and have them an enough opportunity to have a hands-on experience with synchrotron. So I think this is one area that we can emphasize. Look, we also need to expand a little bit in beam time capability and supporting step capability to bring in undergrad students and make sure we have an environment where we can bring in undergrad students or minoritized group of students, and then let them, have enough time to run through the experiment and learn from it. So I think that's one way to actually, leverage the emphasis on equity and all that recent improvement.
I guess with the remote access these days, then maybe you can consider how to bring them to remote first, right? To have some flavor of the experiments before bringing them to the beamline. This is like a partially training sessions.
So basically to get training how to data was collected and data analysis. When they know how the data.
Not only that, I mean, you see the beamline computers, you try to understand how the experiments are done. Although you're not there, you can still get a pretty good idea, how the screen looks like, which buttons to push and everything. And then you can get on.
Yeah, I think that's a great idea. But I also want to bring up this analogy that the online education would never match the experience you would get in person.
Yeah.
So
I agree.
Yes, I agree. By doing hybrid approach, you will be able to bring their level to certain intermediate level before bringing to synchrotron. But
I think that would be more efficient to do it.
Right. But I'm still afraid of putting them in a very crunchy situation with a graduate student and postdoc where they want to finish their work, and the education or training of undergrad student they brought in is a less of a priority because of the time limitation. I'm just trying to help here to how we can actually expand our capability and beamline capability to accommodate more sort of like, undergrad education component that seems to be an emphasis of NSF.
Okay, thanks. Peter, do you want to say something?
Yeah, I like Dan's point. Bending magnets can play a role here because there's less pressure on a bending magnet beamline. And we've run what we call hands-on virtual workshops in various techniques. And this year's Neutron and X-ray summer school, we ran remotely. And in that case, it was rather successful because we only had I think 4 or 5 people there, and we collected a data set. We went through the whole alignment process. We went through a data analysis. Yes, this was something we knew the answer to. But we actually had the students download the analysis programs and have it working before the summer school started. And it went very well. And we've actually had really good feedback from that. And the best feedback is when we attract a new student who hadn't considered doing the technique and is now interested. So, but the bottleneck there is the beamline scientists are in the best position to do this. And we're running at this time lots of remote experiments, plus our regular user programs, plus keeping the beamline running. So, it's a human capital problem at the beamline.
Yeah, but what you'll have in a new organization, outreach programs that will be under some committee and with a close communication with the community, that probably will help to solve the problem.
But you still need the talented lecturers or beamline scientists that communicate.
Unfortunately, yes. But yeah.
Fortunate.
Or
It's job
absolutely
security.
yes. Or absolutely yes. Some other things about the beam time situation. My group tried this couple of times and we find it successful, but later it has become very difficult to coordinate, which is that, you know, when you do experiment at IDD, sometimes you synthesize sample and then you find that the that's decompression measurement can be done at bending magnet beam line. So we twice coordinate with, you know, beam time at BMC. We were able to save quite a bit of time at IDD while we can bring samples to BMC so that we can utilize both beam lines at the same time. But that coordination has become a lot more difficult later on, so we gave up. But, you know, if there are actually ways to, you know, leverage the existing capabilities, like BMC is right next to IDD. So if we can have those two beam lines, beam time back to back, you know, we can save some time for the IDD while we can achieve the goal by putting some, you know, low leverage samples into the BMC.
Yeah, it's called integrated approach. Yes, that's basically what we have to consider. And it will be much easier when we have one organization, but not like a different. Yeah, that could be done. Suki, do you want to get your point in, or you're fine?
Oh, this is actually a good moment for me to just to follow up on what Dan said, because that's exactly what I was talking about in my comment in terms of leveraging combinations of techniques. I think there's some science that we can uniquely do if we can measure one sample with multiple different techniques. And it's very difficult to coordinate beam time to have access to, you know, for example, sector 3 and sector 13 in quick succession with the same sample, you know, and I think that sort of coordination is something that we should think about how to do going forward. Because there have been some sorts of experiments that have been impossible.
Yeah, unfortunately, every sector has own schedule, and if you insist, we will try to accommodate. But yeah, in general, it's difficult, but still should be possible. But I am not sure. You remember there was HP Sync that was supposed to do this stuff? I think it's not very kind of like promising to get some external organization to do that. And like within new one, I think it should be possible if we will, if user want to do that. So. Okay. Is there any suggestion you might have to improve interaction between synchrotron user, office, beamline staff, and users? So that's basically what Suki say right now. So if you have some samples that need multiple technique, it will be great to combine. But yeah, as I say, it should be possible, but at this time it's very difficult. Actually, what I have question to a user, so how many we have? Still 65. Is there an issue with the proposal system, submission, review process, rating, feedback, beamline allocation procedure? Some of you probably unhappy not getting beam time. Some you happy getting beam time. But how is it in general? Are you satisfied with the review process, or you want to have something differently? Okay. Silence means that everyone agrees that
satisfied.
Okay.
Well, it's like playing the roulette wheel with, you know, red versus black with the reviews you get. I mean, it's like, okay, all right, this will review well next time. So I think there is a randomized component that I don't have a great idea for how to get away from it in terms of the, how they are reviewed. I'll just say that. You know, I can look at past beamline proposals and go, viewed as terrible one cycle, viewed as great the next. Okay, whatever.
Yeah, that's a typical thing we see. You know, same proposal can review very differently.
Yep. And as I can see the same proposal for different synchrotrons. It's also true. So I think we already late a little bit already, 11 past 6. I think we can conclude for today. It was a great day, and thanks everyone for attending our workshop. And tomorrow we will focus more on science. Prepare all your questions, and remember that you can still earn $200 in your pocket. Okay, guys.
Right.
And if you
Thanks.
haven't done so far, please make sure that you fill in the survey. We already have a good response.
Right.
Have a
Thank
nice
you.
evening or morning or whatever.
Okay, bye-bye, guys.
Bye.
Bye.